Ransomware does not take down your network instantly. It starts with one compromised machine and then it spreads. The real question is not, can you stop the attack? It is, can your network stop it from spreading? Welcome to Beyond Uptime, a channel where we talk about network assurance, cyber resilience, and autonomous infrastructure. Most networks are designed for connectivity. Users can reach servers, servers can reach each other. Everything is open enough to just work. And that's exactly what ransomware exploits. Because once it's inside the network does the rest of the work. In the last video, we talked about micro-segmentation, controlling access paths. But this is different. Micro-segmentation reduces risk. Ransomware resilience assumes a compromise and limits the damage. A resilient network does just these three things: limit movement, protect critical systems, preserve recovery. If your network can't do this, it is not a resilient network. Ransomware spreads laterally, from one machine to another, mostly inside your network. If users can freely reach servers and servers can freely reach each other, then one infection becomes many. A resilient design breaks these paths. Only required communication is allowed, everything else is blocked. And this is where most designs fail. Even if you detect the attack, can you still recover? Or is your backup path using the same network that's now compromised? A resilient network protects recovery paths because during an attack, recovery is everything. Let me show you this in the lab now. Here we have a simple segmented environment. The user machine is in the user zone, the media server is in the application zone, and this node represents recovery infrastructure. Now, under normal conditions, approved traffic still works. You can see the baseline traffic running at around 5 megabits per second, and that is our normal background traffic between the application and recovery side. The user should still be able to access the approved media server. So if you go to VLC and try that, as you can see, the media plays fine. So the network is not broken and applications are still working fine. Now, let's treat this user machine as compromised. From the user machine, I'm going to simulate lateral movement towards the recovery zone. Now, this is not real ransomware. It is just a simple scan to show what happens when a compromised endpoint tries to discover and reach protected services. So I'm going to use this command from this user machine, which is kind of an attack simulation. So what we are doing here is we are trying to scan all these various ports, 22 used for SSH, 80, 443, 3389, and so on and so forth. And we are setting a loop here so that we can see what's happening in real time. And see here, you can see the result. The host is there, but the critical ports are filtered. SSH, HTTP, HTTPS, RDP, and the management port are not reachable from the user zone. Now, on the firewall, I'm going to run this command. And you'll see all the denial logs here. So this is being blocked at the network policy layer. And that is the key difference. The endpoint may be compromised, but it cannot move into recovery infrastructure freely. And notice normal approved traffic is still running fine. The baseline traffic continues, the media service continues. So we're not just blocking everything blindly, we are permitting what is required and denying what creates blast radius. This is what ransomware resilience looks like from a network design point of view. Not perfect prevention, containment, protection of recovery systems, and enough visibility to see abnormal east-west behavior when it starts. Ransomware resilience is not about adding more tools. It is about designing your network to expect compromise and survive it. If you found this useful, please subscribe to Beyond Uptime. We are breaking down how modern networks actually deliver assurance, resilience, and security. And in the next video, we'll look at why east-west visibility is critical and what most networks are still missing inside their own environments. See you in the next one.